Part 2 of Lesson 4, Chapter 2 is on two theorems. The first one is the fundamental theorem of algebra. And the fundamental theorem of algebra simply says that if the degree is n, that means that there are n zeros for that polynomial. Now, sometimes your zeros will be real zeros, and sometimes your zeros will be imaginary zeros. But a third degree polynomial is going to have 3 zeros. If it crosses the x-axis 3 times, then all 3 zeros are real. If it crosses the x-axis once, then it has 1 real and 2 imaginary. The next theorem is called the conjugate root theorem. And this is talking about when you have imaginary zeros. Anytime you have an imaginary zero that is in the complex form a plus bi, then its conjugate, a minus bi, must also be a zero. So as an example, if we had 4 minus 3i as a 0, then we know that its conjugate 4 plus 3i would also have to be a 0. So with that being said, we're going to do problems where it asks us to write a polynomial function of least degree with real coefficients in standard form with the given zeros. So since it's telling us that it has a 0 at -3, we're going to write x plus 3. Since it says it has a 0 at 1, a multiplicity 2, we're going to write x minus 1 to the second power. And then since it has a 0 at 4i, we're going to write x minus 4i. And we'd also have to write x plus 4i, because certainly we know that if it has an imaginary 0 like 4i, then it's got its conjugate also as a 0. So this looks to me like it's a 5th degree polynomial. And this is a really good function that's going to have zeros at -3, 1 with a multiplicity of 2, and also at 4i. But we have to put it in standard form. That means get rid of the parentheses. So I'm going to have to do some foiling. When I do some foiling, I'm going to leave the x plus 3 alone. I'm going to take the x minus 1 and square it. That's going to give me x squared minus 2x plus 1. And if I FOIL out these two conjugates, you can see that I get middle terms that should cancel each other out. So the 4xi and the -4xi cancel each other out. And so now I'm going to take this binomial, the x plus 3, and multiply it with the trinomial, x squared minus 2x plus 1. I'm going to simplify that in just a minute by combining my like terms. And on this binomial that we multiplied with conjugates, you get x squared minus 16i squared, which simplifies into x squared plus 16, because I squared is equal to -1. So if I do some simplifying, this first set of parentheses would simplify into x to the third plus x to the second minus 5x plus 3. Still have the x squared plus 16. And now if I multiply these two factors, we would get x to the 5th. Let's do it this way. I'm going to take x squared times each term. Now I'm going to take 16 times each term. Now I'll combine my like terms, and that would give me a function in standard form of x to the 5th plus x to the 4th plus 11x to the 3rd plus 19x squared minus 80x plus 48. Take my result, and if I try to graph it, I get a graph that looks like this. And you can see that we can't see all of the interesting part, but we can see that it crosses at -3, and then it touches at +1. And that lets us know that we did all this algebra right, because the original problem said we'd have a 0 at -1 and a 0 at 1 of multiplicity 2. And that's what this graph is showing us here. Second example, same type of problem. It says, write a polynomial function of least degree with real coefficients in standard form that has the given zeros. So since there's a 0 at -2, we're going to write x plus 2. Since there's a 0 at 4, we're going to write x minus 4. Since there's a 0 at 3 minus I, we're going to write x minus 3 plus I. Remember, you're always using opposites with your zeros. If there's a 0 at 3 minus I, we must also have another 0 at its conjugate at 3 plus I. So then our last factor would be x minus 3 minus I. And so now we'll start to eliminate the parentheses by putting it in standard form. We get x squared minus 2x minus 8 by foiling the first two binomials. Now these last two trinomials are conjugates, so if I foil, I'm going to have several terms that cancel. This negative xi is going to cancel. You're going to see that in just a second. That positive 3i is going to cancel. That positive xi is going to cancel. The negative 3i is going to cancel. The negative I squared is going to simplify. So if I rewrite that second grouping, I'm going to get x squared minus 6x. And you can see that I can cancel this and this. I can cancel this with that. And so I end up with just a 9 plus 1, which is 10. And now I have to take these two trinomials, multiply them. Now I take the negative 2x times everything. Take the negative 8 times everything. Combine all your like terms. And that would give us a function in standard form that looks like this. So the last thing I'm going to do here is I'm going to graph this to see if it has the right x-intercepts. It should cross the x-axis at -2 and at 4. So if we graph this, you can see I've got it entered here on the graphing calculator, and so now when I graph it, you can see it crosses at -2 and at +4. And it was supposed to cross at -2 and +4. That ensures that we have it in the correct standard form.